Morocco was struck by a devastating earthquake of 6.8 magnitude on 8 September. And you know what? This was the strongest in over a century. The epicenter was located in the Atlas Mountains region. This quake, which was relatively shallow, resulted in widespread destruction and loss of life. Over 2,000 people were reported dead and more than 30,000 individuals in Marrakesh and surrounding areas were affected. You might be wondering, what are all these terms magnitude, shallow earthquake? Let me tell you, there's a lot more to it. But don't you worry, I'll make you understand all we need to know about the earthquake phenomenon. So, first of all, what is an earthquake? See, an earthquake in simple terms is just shaking of the earth. Know that it is a natural event. It is caused due to the release of energy which generates waves that travel in all directions. Then, why do you think the earth shakes? The release of energy occurs along a fault. A fault is a sharp break in the crustal rocks. See, the rocks along a fault tend to move in opposite directions. As the overlying strata presses them, it is the friction that locks them together. However, their tendency to move apart at some point of the time overcomes that friction. As a result, the blocks get deformed and eventually they slide past one another abruptly. This causes a release of energy and the energy waves travel in all directions. That point where the energy is released is called the focus of an earthquake, or we can even call it as the hypocenter. The energy waves traveling in different directions reach the surface now. The point on the surface, which is nearest to the focus, is called the epicenter. This is what we have mentioned earlier. Know that it is the first one to experience the waves and is a point directly above the focus. Now, let us dig deep into the topic and know about earthquake waves. See, all natural earthquakes take place in the lithosphere. It is sufficient for now to note that the lithosphere refers to that portion which is of the depth up to 200 kilometers from the surface of the earth. An instrument called seismograph records the waves reaching the surface. Note that the curve shows 3 distinct sections, each representing different types of wave patterns. Now, what are these? See, the earthquake waves are basically of 2 types, which are body waves and surface waves. Body waves are generated due to the release of energy at the focus and move in all directions traveling through the body of the earth. That's how they got that name. These body waves then interact with the surface rocks and generate new set of waves called surface waves. These waves move along the surface and the velocity of the waves changes as they travel through different materials with different densities. The denser the material, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. Now, there are 2 types of body waves, which are P waves and S waves. P waves move faster and are first to arrive at the surface. These are also called primary waves. The P waves are similar to the sound waves, which means they travel through gaseous, liquid, and solid materials. S waves arrive at the surface with some time lag. These are also called secondary waves. An important fact which you need to know about the S waves is that they can travel through solid materials only. This characteristic of S waves is quite important because this has helped scientists to understand the structure of the interior of the earth. What does the reflection and refraction do? Reflection causes the waves to rebound, whereas refraction makes waves move in different directions. The variations in the direction of the waves are inferred with the help of their record on the device seismograph. The surface waves are the last to report on the seismograph. These waves are more destructive. They cause displacement of rocks and hence collapse of structures occurs. Now, how do these earthquake waves propagate? See, different types of earthquake waves travel in different manners. As they propagate, they cause vibration in the body of the rocks through which they pass. P waves vibrate parallel to the direction of the wave. This exerts pressure on the material in the direction of propagation. As a result, it creates density differences in the material, leading to stretching and squeezing of the material. Other three waves vibrate perpendicular to the direction of propagation. The direction of vibrations of S waves is perpendicular to the wave direction in vertical plane. Hence, they create troughs and crests in the material through which they pass. Surface waves are considered to be the most damaging waves. Now, let us discuss a small concept called emergence of shadow zone. These earthquake waves get recorded in seismographs located at far off locations. However, there exist some specific areas where the waves are not reported. Such a zone is called the shadow zone. The study of different events reveals that for each earthquake, there exists an altogether different shadow zone. It was observed that seismographs located at any distance within 105 degrees from the epicenter recorded the arrival of both P waves and S waves. However, the seismographs located beyond 145 degrees from epicenter record the arrival of P waves only, but not that of S waves. Thus, a zone between 105 degrees and 145 degrees from the epicenter was identified as shadow zone for both the types of waves. The entire zone beyond 105 degrees does not receive S waves. The shadow zone of the S wave is much larger than that of the P waves. The shadow zone of P waves appears as a band around the Earth between 105 degrees and 145 degrees away from the epicenter. The shadow zone of S waves is not only larger in extent, but it is also little over 40% of the Earth's surface. You can draw the shadow zone for any earthquake provided you know the location of the epicenter. Now, let us talk about different types of earthquakes. See, the most common ones are tectonic earthquakes. These are generated due to sliding of rocks along a fault plane. But a special class of tectonic earthquake is sometimes recognized as volcanic earthquake. However, these are confined to the areas where you have active volcanoes. Next, in the areas of intense mining activity, sometimes the roofs of the underground mines collapse, causing minor tremors. These are called collapse earthquakes. You all need to know that the ground shaking may also occur due to explosion of chemical or nuclear devices. Such tremors are called explosion earthquakes. The earthquakes that occur in the areas of large reservoirs are referred to as reservoir-induced earthquakes. Now, we have seen the term magnitude in the news. So let us see how do we measure the magnitude of the earthquakes. See, the earthquake events are scaled either according to the magnitude or intensity of the shock. The magnitude scale is called the Richter scale, and this magnitude relates to the energy released during the quake. The magnitude is expressed in absolute numbers of 0 to 10. Then, the intensity scale is named after Messali, who is an Italian seismologist. The intensity scale takes into account the visible damage caused by the event. The range of this intensity scale is from 1 to 12. Now, if you look at the effects of the earthquake is a natural hazard. Some of the immediate hazardous effects of earthquake are ground shaking, differential ground settlement, land and mud slides, soil liquefaction, ground lurching, avalanches, etc. These listed above have some bearings upon landforms. There are other effects like ground displacement, floods from dam and levee failures, fires, structural collapse, falling objects, tsunami, etc. These may be considered the effects causing immediate concern to the life and also properties of the people in the region. The effect of tsunami would occur only if the epicenter of the tremor is below oceanic waters and the magnitude is sufficiently high. Tsunamis are nothing but the waves generated by the tremors and not an earthquake in itself. Though the actual quake activity lasts for a few seconds, its effects are devastating provided the magnitude of the quake is more than 5 on the Richter scale. Now, as we had talked earlier that earthquake is a natural hazard, if a tremor of high magnitude takes place, it can cause heavy damage to the life and property of people. However, not all parts of the globe necessarily experience major shocks. Note that the quakes of high magnitude means on the Richter scale, the rating should be 8+, are quite rare. They occur once in 1 or 2 years, whereas those of tiny types occur almost every minute. Now, where are the earthquakes more common? See, the foci of the earthquake in the areas of mid-oceanic ridges are at shallow depths, whereas along the alpine Himalayan belt as well as the rim of the Pacific, the earthquakes are deep-seated ones. Coming to India's case, National Center for Seismology under the Ministry of Earth Sciences is the nodal agency of Government of India for monitoring earthquakes in and around the country. For this purpose, NCS maintains a National Seismological Network, which in short is called the NSN, consisting of 115 observatories spread across the country. The information of the earthquakes reported by the NCS is being disseminated to concerned central and state disaster authorities in least possible time to initiate the adequate mitigation measures. Secondly, seismic microzonation of cities in India having population of 5 lakh and above is also considered. The purpose is to generate inputs for constructing earthquake risk resilient buildings or structures to reduce and mitigate the impacts of earthquake shaking and for minimizing the damages to structures and loss of lives for safer urban planning. Additionally, National Disaster Management Authority of India is engaged with conducting regular awareness campaigns every year through print, electronic as well as social media from time to time to sensitize the programs on prevention and preparedness for building safety from earthquakes. Seismic zonation map of the country given by the Bureau of Indian Standards has categorized into several seismic zones which are Zone 2 to Zone 5. Zone 5 is seismically the most active region while Zone 2 is the least.